Hello everyone. In this video, we will be solving problem number 135, minimum difficulty of a job schedule. The problem statement is, you want to schedule a list of jobs in D days and the jobs are dependent. So you have to finish everything in sequence. Now we have been given a variable called D, which says how many days we need to finish the job in, and an array with the list of jobs based on the difficulty. And we need to find out the minimum difficulty of a job schedule based on the days and the jobs that are given to us. If we are unable to find the schedule, we need to return -1. Let's look at example number 1 to understand the problem better. So we are given the job difficulty array with 6, 5 all the way to 1, and the number of days is 2. Basically, we need to finish all of these jobs in 2 days. The best course of action will be to finish all of the jobs that have a difficulty level of 6 or below in day 1, and then on day 2 finish 1. Even though you can finish the job with difficulty level 1 on the same day as the other, the constraint that is given to us is we need to have at least one job per day. So based on this combination or breakdown, we will have 6 on our first day as a job difficulty and 1 on the second day. So our result is going to be 7. Let's look at example number 2 to get a better clarity on some of the edge cases. Here we have 3 jobs with equal complexity or difficulty, and we are given day as 4. Now in any combinations, we cannot complete 3 jobs in 4 days. We will have 1 day with no job at all, so we will return -1. In example number 3, we have total of 3 jobs and 3 days. So here we don't need to do any combination as such because we need to have 1 job per day. So we'll have the total of 3 as our job difficulty across all days. So we will have 3 as a result. I'll do DS3 so that we can cover a couple of more combinations. Let's identify what are combinations we can build on day 1. Starting with 6, and we can do 6 and 5, 6, 5, 4. Other than that, or else we will not be having enough jobs for day 2 and day 1. So for the combination that we have written, let's identify the maximum job difficulty. So for the first one is 6, second one 6. Actually, all of them will have the same difficulty. Now going further on day 2, if we start with the first day and only one job 6, what combination do we have here? We can do just 5, we can do 5 and 4, we can do 5, 4, 3. All of those combinations are possible when we start with only 6 on day 1. Similarly, if we start with 6 and 5, the combination that we are left with is 4, 4, 3. For the next batch, 3, 3 and 2. And for the last one, we only have 2. So for these job batches, let's identify the maximum job difficulty. The first one will have 5, the second one will have 4, third one will have 3, the last one will have 2. Now just like before, we'll have to identify the next batch of jobs for the last day based on the jobs that we ran on job day 2. This is comparatively easy because this is the last day, so all we need to do is iterate through all of the remaining jobs or batch them all together. So if I take 5 as a starting point, I will have 4, 3, 2, 1, 3, 2, 1. For the next combination, starting with 4, I will have 3, 2, 1, 2, 1, 1. Here I will have 2, 1 and then 1. So we'll have different job difficulty. So 4, 3, 2, 1. Now that we have identified the job difficulty for each batch on each day, all we need to do is start the iteration and connect all of the right combinations, sum that up and see if it is the minimum. For example, if I start with this 6, let's say if I go to the first pair, so which is 5, so I'll have 6, plus 5 plus, and from here I have only one combination available, which is 4. So my total is 15. Now if I try a different pair where I'm checking 6 with this combination 5 and 4, so it will be 6 plus 5, but with this as my second day job, I will have to change my job on the third day, which will be 3 to 1, and the maximum is 3. So my result will be 14, which is less than the current minimum. So I will update my minimum to 14. Similarly, I will continue the recursion until I find the minimum value. We are trying to break this problem down into smaller sub-problems and then solve it at a day level. Another thing to pay attention here is some of the jobs can repeat itself for the same day. For example, here the job 321 repeated multiple times on day 3. So for these kind of combination, we can try to optimize our algorithm using memoization, save the result of this pair, like what is the maximum job difficulty in a dynamic programming array. So similar to 3 to 1, we have 2 1 that is repeated. So we can use dynamic programming with memoization to optimize our algorithm. I hope you were able to follow this explanation and this solution. This problem, even though it is marked as hard, it isn't really hard. I would say it's a medium level problem, because after breaking this problem down into this smaller problems and then solve it recursively using depth first iteration, it doesn't seem that difficult anymore. So let me show you how the same solution can be implemented using C#. Starting in the main method, we have some validation, like to make sure that the job difficulty array is not null, the length is greater than 0, and the job difficulty length is not less than the number of days. If any of the conditions is met, we return -1. The next step is where I am initializing a dynamic programming array. It is a two-dimensional array where the first dimension is the day and the second is the index where the job batch will begin. So I'm initializing all of the entries and setting the value as int32.maxValue, so that later on we can compare it with the calculated value to identify which is the minimum value. I have created this helper method which helps us iterate and create the batches recursively using depth first approach. Whenever we call this method with the day as 3, for example, and the starting point or the breakpoint is going to be 0, it will start this for loop and run until the job difficulty dot length minus d, and then whatever is the value in this max job value variable, it will save it in the dynamic programming array. Inside the for loop, we are calculating the current job value. This is where we are batching all of the jobs in the array and comparing what is the maximum value out of the previously calculated ones. The next step is where we are calculating the value of the job difficulty for the remaining days after that. We are calling the DFS method again and then asking it to do the calculation for the next day. That's why we have d minus 1, and then incrementing I because we want to start the next job from the next index. Once we get the remaining jobs here, we are then trying to calculate what is the minimum combination that we can build. So we are adding current job value and the remaining job that we calculated, summing them up together, then comparing it with the previously calculated max job value. Whichever is the minimum gets saved in this variable, and later on it is assigned to the dynamic programming array. If the day is 1, which means we are on the last day, we don't really need to do any iteration for the next day, given it's the last day. So what I'm doing here is just iterating through all of the remaining jobs in the array based on the breakpoint that we receive, and then calculate the maximum value and then assign it to the DP array. Check here to see the value of DP for that particular day and breakpoint. If the value is equals to int32.max, it means that we have not yet iterated through that combination, so we should continue the flow. But if the value is not max value, It means that we have already done the calculation, so we don't need to repeat the calculations again. So I just skip the if statement and then directly return the value from DP. I hope you are able to follow my explanation and this source code. This code is available on my GitHub repository. Feel free to check that out. If you have any questions, comments, or suggestions, feel free to reach out to me. I would be happy to hear any feedback from you. Thank you for watching this video, and I will see you in the next one.